Hello, people of the world. My name is Lorenzo Perella. This is the first time I'm doing my quiz for video and forever. Well, ever, actually. Anyway, this is what I'm really trying to do right now. As you can see, first piece of this is figuring out that you have a glass with a height of 1 centimeter of water. And I'm trying to find the height of the water in the glass when you add the ice cube to the water, and the final result is in millimeters. So, in order to do this, first you look into the pieces that are given and illustrate the following. Illustrate the following. And that you know that the diameter of the glass is 3 centimeters and that the ice has a diameter of 2.5 centimeters and a height of 1. So to find the height of the water once the ice is in, what you first need to do is understand the density of the ice. As you can see, the density of ice we find from our table to be 0.917 kilograms per meters cubed. And you take this in order to utilize the volume of the ice to be 2.25 E minus 2 meters squared times pi, which is the radius of this cylindrical piece of ice. Oh, my apologies. And then you have to multiply that by 1 centimeter. This is funny. I did not put that in this there, but the end result should be 4.9087 E minus 6 meters there. From there, you take the density formula of mass divided by volume, and we know the density of ice to be 0.917. Multiply this by the piece that's given, and then you would end up with 4.5 E minus 6 kilograms. From there, find that in order to get the volume, the volume of water equals the base times height and the volume of the displaced water, which we can illustrate it as such to then be rewritten as the volume of the water plus the volume of the displaced water equals the height of the water multiplied by the base. And then we isolate that to get the height equals the volume of the water plus the volume of water displaced divided by the base. Now we know both components as calculated here, which allows us to then find that the end value is about 0.399 millimeters. And if you add that to the factor of 1 centimeter being 10 millimeters, then the end result is 10.4 millimeters. And this is within acceptable margins for when I did an experiment like this with my own glass of water and a piece of ice. I noticed that the height of the water did not change dramatically. As such, it is fair to say that this change in height is within acceptable margins of error for this experiment. I hope this video finds you well, Professor Wellman, and to all others who view it in the future. Thank you and have a pleasant evening.